2 ones after that. Right. The key thing normally on these questions is to make sure you adhere to the format they're giving you. In general, there'll always be 2's complement unless they specifically state otherwise. But so just read the question, like I have to do for the question. Then the secondary thing that we didn't think was going to be that much of a problem was looking at the number properly. Yeah. Right, okay, so minus 2.5 in floating point. You will automatically normalise these when you write them down, so they might tell you to write it in normalised form, but you're doing that anyway. Okay, so the first thing we've got to do is say, okay, we've got to write it down. We're not going to try and write it straight into floating point, we're just going to do it as a fixed point number. So we're going to put a binary point somewhere, and then we've got a negative. So we're not going to be able to write down minus 2.5 anyway, so we write down what?
2.5.
Correct, 2.5, and then we'll do 2's complement on it to get the right number. Okay, so let's put some column headings in. We need enough integer headings so that we can write down plus. So we need to be able to put a sign bit of 0. So I'm going to put 0, and I'm going to put 2.5, so that's 2. So if we go back that way, we need to put that. Okay, so that's 2.5. So I'm just going to make a note. So I've written 2.5, I know that. And then I just need to form 2's complement on it to get the negative version. Okay, so we're going to go flip, flip, flip. That is the last one, so I'm doing it the quick way. So we stop, write a 1, everything else just stays the same. Okay, so that's the quick way of doing 2's complement. Remember the full way of doing it, we go flip, flip. I'm going to cut this up. Flip, 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 and then we add 1, so we look for the first 0 that way. Make it a 1, everything we went past is a 0. So you're just doing that process, you're just saving having to rewrite the last bit. Use whatever method works for you. If you can do the quick way without cocking up, do it because it's quicker. But if you have to do the flip and add method, do the flip and add method. Remember, that's the 2's complement process, so they might ask you about that. What 2 steps? Okay, so that's going to be now minus 2.5, but we now need to put it in the format we've been given. Oh, put my binary point in. So normalising, we make sure that the sign bit is followed by the opposite bit. So the sign bit is 1. So that's got a note after it, so that's where we need to put the binary point to make this normalised. Remember, normalising maximises our precision. Right, so we need to move the binary point 1, 2, put the arrow on so you know which way you've gone. So our number, and we had what, 6 bits, so we got 1.0110. What did we pad at the end?
0.
Zeros on the right hand side, sign on the other side if you're padding. Okay, so that's my mantissa, so I'm going to get a mark for that, and I'm going to get a mark for showing that I've moved the binary point. So that's 2 marks so far. And because we had to do 2's complement, I'll give you a mark for getting the 2's complement right. Right, the other bit we've got to write down is the exponent. Okay, so we moved it 2 places. So the magnitude is 2, but we need to know what the sign is of the exponent. So the easiest way to think of it, I've made this number smaller, so I need to make it bigger, so it must be plus 2. So I know it's plus 2 because I moved it 2, 4 bits, so my exponent, they're generally always going to be easy, the exponents. So if you cop the exponent up, you just need to go home. Right, so mark for the exponent. So 4 marks in total just for doing that. In this example, that's not an example. Anyone watching this, that is not what the exam marking scheme is. Anyone got any questions about that? 2's complement is 2's complement, so don't like get scared, just get 2's complement. Right, I'm going to write that down because we'll need it for the last bit. So 1.01. Right, okay, so next one. 3 1/8. I was going to write it as a decimal. Okay, but I don't know. I would hope that the example, because you haven't got a calculator, wouldn't start giving you stupid things. What's 3 1/8 as a decimal? Those maths brains in the room.
375.
Just multiples of 125. That's all it is. Okay. So yeah, I hope they give you something sensible. So that's what it is, but as a fraction it's easier anyway to work. So again, we're going to put binary point down, and we want to be able to write 3/8. Now it's a positive number, so I need a sign bit of 0. So I'm just going to put a few column headings in, but I need to go back this way until I can get to 8ths. I'm going to go to 16ths. Not that I need it, but I'm going to anyway. Right, so it's a positive number, so sign bit goes in. There's none of those. Right, so 3/8, you've got to actually be able to do maths in order to solve this one. Well, there is an easy way of doing it without maths at all. Look for the denominator. So we've got 3/8. So we're starting at this column, and then you're going to write down the number 3 in binary. And that's how you do it. So no maths involved at all, just do binary. Alright? I would cock it up. 3/8 and that's a quarter, but easy cock up. Okay, so if you've written down that before we try and normalise it, I'll give you a mark. That's 1 mark. Right, we're going to normalise it. So we want a sign bit of 0 followed by a 1 because it's a positive number. So actually, we want the binary point to go there. So it's currently there, so we're going to move it to there. 1 place. So the exponent is of size 1. But this time, we started with a number and we've made it bigger. So when we take this back, we need to shrink it again. So it must be -1. Okay? So you get a mark for moving the binary point the right way by 1 place, but you'll then get a mark for writing -1. I expect you to be able to just write -1 in whatever format, because it's all the ones, remember? Okay, so 3 marks for that. Anyone got any questions? No? Right, so we had, if I rewrite that out, so that's 0.110 pad with 2 zeros. Get marked for the final mantis. In the questions, they're generally, you'll be lucky if you get 3 marks. 1 mark for working, 1 mark for a mantis, and 1 mark for an exponent. They generally won't give extra marks because you have to do 2's complement.
3 then.
So you got a mark for that initial one, a mark for showing the binary point moving 1 place, a mark for the final mantissa, and a mark for the exponent. So 4 marks again. On that one. Right, so we ended up with 0.1. Right, now we want to add them together. So it's an identical process to adding 2 integers together, apart from the fact that the exponents need to be the same. Okay, so in reality what you would do the minimum amount of shifting. But it's actually a lot easier if what we do is we unnormalise these completely and add those 2 numbers together. In my opinion. That's my opinion. You can do it a different way. Okay, but it's easier to unnormalise that, add them together, and then normalise it again. So if we look at the first number, so we had 1.01100. Right, the exponent was 2, so this needs to get 2 places bigger, which means the binary point needs to come this way. So we're going to go 1, 2. So it ends up there. So the first number we've got to add is going to be 1, 0, 1, 1. Make sure you've got the binary point because that's crucial for adding this up properly. So we've got that number and we're going to add something to it. Right, the other number, so we had 0.11000. Right, this one's got to get smaller, so the binary point has got to go that way when we normalise. We haven't got anything else, so we need to pad out. Just put some zeros in there so that we remember that's called sign extending, so that's just extending the sign bit, just copying it, duplicating it. Right, so it's going to go there. So when you're writing these down ready to add up, write the binary point in first for the second number. So you know they've got to be in alignment, so the columns are equal. So we've ended up with 0, 0, easy to cock up, 1, 1. We don't need to put any more of those zeros in because that's lined up, and we just need to pad that out. Okay. Right, we're now at a stage. So if you've got that and that, you've got a mark. So they're the two unnormalised numbers. Right, and whenever we do binary arithmetic, they'll expect us to show the carries. You'll always get a mark for showing carry through the process. Okay, if there are any carries. I don't know whether there are with this. Right, 0 and 1 is 1. What is the carry? Yeah, I've just gone 0 and 1 is 1. And then I've not written a carry. But in reality, what is the carry? 0. Remember, if we're doing a full adder, it generates a carry each time. And that carry can't be indeterminate. It's got to be 0 or 1. Either there is a 1 to carry or there's a 0 to carry. Because that feeds into the next full adder. Okay? I'm not going to confuse that by writing that down. Right, 0 and 1 is 1. 1 and 0 is 1. Put my binary point back in. 1 and 0 is 1. A 0. That's a rubbish 0. Hang on. What's the best way of rubbing that out without moving it? Working. No. And then 1 and what? No. 1 and 0 is 1. Okay? So I'll give you a mark for doing that properly. That's not the final answer because we've got to normalise it. Right, we've got a negative answer. Does that appear to be probably right that we've got a negative? Yeah, so you can always double check these even without having to convert it back. We started with a bigger negative number than we did a positive number, so the answer should still be negative, which is what we've got. So we're going to normalise this. So the sign bit is 1, so we need a 1 followed by 0. So we're going to move the binary point 1, 2. 2 there. So the final mantissa that you're going to get is 1.011. I'm going to get this right. 1. 6 bits, just double check. I don't know how brutal they're going to be if you just miss a bit off, even if it was 0. Okay, so always double check. If you need to pad on the right with zeros. So you're going to get a mark for getting the mantissa. And then we shrunk the number by 2. So the exponent is 2 plus 2. So the exponent should have been that. You get a mark for that. So there was 5 marks for that. You won't get 5 marks in an exam question, but they'll build it up like this. There'll be a sequence of things. So the total for that was, with my maths powers, 13. Anyone got any queries on that? It is what it is. It's binary, it's floating point, and it's arithmetic. Right, I'll upload that